Good morning to all. Today we'll see a lecture on linear time invariant system. So I have told you what is mean by time invariant system. So time invariant system is what? If the input output characteristics does not change with the shift of time origin, it is known as time invariant system or shift invariant system. So what do you mean by linear time invariant system? The system which satisfy properties of linearity and properties of shift invariant or time invariant, it is known as linear time invariant system. The system which satisfy both the condition of linearity and the condition of time invariant, it is known as LTI system. As you can see here, let me take the pointer. As you can see here, if x of n is my input, t is a system, will be the output as y of n. If there is change in the input with respect to the system, also there is a change in output also, that is known as LTI. And linearity, I have told you earlier, system as linearity, there is no change in the input signal with respect to that system. Now why do you want the LTI system? Because the large collection of mathematical techniques is available in LTI systems, and many practical systems are either LTI or can be approximated by the LTI systems. Most of the practical systems are LTI, that is linear time invariant systems. Now we'll see the impulse response of a LTI systems. Now what is mean by impulse response? Suppose you have a system, let me draw here. Suppose you have a system, so consider this is my system as a t. So it will be your input, okay, I, it will be output, I am considering it as O. So the impulse response means it is known as output. Response means what? It is known as output. Impulse response, so you consider the impulse response here, it is as a output response. So here we have known the output response as a what? The output response as a impulse response. So to have a output as a impulse response, what will be the input? So input is nothing but the impulse one. So when your input is impulse, then the output response is known as impulse response. So impulse response means what? So impulse means what? Input is nothing but what? Del of n. When your input is equals to del of n, the response which you will get, that response is known as impulse response, and that is denoted as h of n, or you can consider it as a y of n also, because it is the output response. So when input to the system is delta function or impulse function, output which will you have for that particular system, that output is known as impulse response. What do you mean by step response? If the input to the system is step, that means if input to the system is u of n, the response is known as unit step response. The response is known as what? Unit step response. You can consider it as y of n. Okay, now we'll see here I have mentioned the del of n as input, so h of n is equal to t is your system and del of n is your output. That response is known as impulse response. Now here I have considered the input as a delta function, so you can see here input as a delta function and you will get output as the impulse response. Now the LTI system is completely characterized by single impulse response. As you see here, x of n is my input, h of n is my linear system, y of n is my output. Let me tell you the equation. Y of n is equals to t, that is your system, x of n, and the formula is become like this: summation for k is equals to minus infinity to infinity x of k h of n minus k. So this x of k is nothing but x of n only, and this h of k is nothing but h of n only. Okay, we have changed the notification as k. So this equation is known as x of n, and this symbol is known as convolution symbol. This symbol is known as what? Convolution symbol. X of n convolved with h of n, and the formula is what? Summation for k is equals to minus infinity to infinity x of k h of n minus k. So I will tell you the convolution. Here it is what? Here it is summation. Summation of what? Summation of x of k with h of minus k, and after that we have to shift with number of samples, that is n, and you multiply and then you add. That is the meaning of convolution. What we will do? First we have to multiply x of k with h of n minus k. Whatever the terms you are having, you have to summation, you have to add. So we will be getting the convolution between two signal x of n convolve with h of n. We will see in the upcoming slides. So I have told you the h of n minus k is what? Response of a system to the input, that is unit sample sequence at n is equals to k, and this symbol is known as convolution sum. This symbol is known as what? This symbol is known as convolution sum. So x of n, you have to remember this formula. X of n convolved with h of n is equals to, that is the formula for LTI system. K is equals to, summation for k is equals to minus infinity to infinity x of k h of n minus k. Convolution between x of n and h of n. Now we will see. Now to have a convolution, we have to see linear convolution and circular convolution. So first we will start with linear convolution. So in linear convolution, the total number of output samples it is given as, the total number of output sample it is given as. So output samples is what? The output samples in the equation of y of n, it is given as like this: samples of x of n plus samples of h of n minus 1. So m is nothing but the samples of x of n, h is nothing but the samples of n is nothing but the samples of h of n, m is nothing but the samples of x of n minus 1. In some books they have written y of n is equals to L plus m minus 1. So it can be also okay, but you have to remember the first term is nothing but the samples of x of n plus samples of h of n minus 1. This number of output samples you will have in linear convolutions. When we are going to solve a linear convolutions, the number of samples in output sequence is equals to samples of x of n plus samples of h of n minus 1. Now most of the time linear convolution is used for non-periodic signal. If the signal is non-periodic, then we are using linear convolution, and if the signal is periodic, we are using circular convolution. Now we have to remember, so I have told you earlier, total number of convolution, that means total number of output samples for a non-periodic signal is equals to, if the signal is non-periodic, and the total number of output samples or total number of convolution is equals to m plus n minus 1 samples of x of n plus samples of h of n minus 1. And for the periodic signal, that means for circular convolution, it is nothing but the order of period. See, order of period, that much number of convolution will be having for periodic signal. Now we will see linear convolution. So we will see linear convolution using graphical method. What steps you require to solve the linear convolution using graphical method? So first, x of n and h of n will be given. See, like here you can see x of n and h of n is given. So this is the signal of x of n, this is the signal of h of n, both are given. Now see, this x of n, it is similar to the x of k, okay, and the h of n, it is similar to the h of k, okay. So just we have to change the notification, instead of n you can write it as k. So x of n you draw it is same as x of k, and h of n you draw it is same as h of k. After that what you require? After that our equation is what? Summation of k is equals to minus infinity to infinity x of k h of n minus k. Okay, so x of k will be same as x of n, and h of minus k first we have to sketch. So h of k is there, you flip or you reverse, it becomes h of minus k, then you shift h of n minus k you put a different value of n, then you multiply x of k and h of n minus k, and then you sum. That is how the linear convolution is taking place. Now how to solve, we'll see. So here it is, as we have seen the operation of signal, how to draw h of n minus k, how to draw x of minus k or h of minus k. Now here you have a question. Find linear convolution of two sequences x of n and h of n using, you can say, using graphical. It is in time domain. Okay, what we have studied, all it is in time domain. In DFT will be seeing it is in frequency domain. So it is in what domain? It is in time domain. We are using the linear convolution or circular convolution in time domain. So x of n is given and the h of n is given. So first step is what? First step, we have to sketch x of n. So arrow is not given, so by default this is your 0th position. Here the arrow is given, so by default this is my 0th position. So here h of n is varying from -1 to 2 and x of n is varying from 1 to 2. That is the range of the given signal. So first we need to sketch x of k, then you need to sketch h of k. X of n will be similar as x of k, h of n will be similar as h of k. Okay, h of n will be similar as h of k. Now what number of convolution will have for these two sequence? So I have told you the formula, samples of x of n. So here what much number of samples you have? You have the samples of x of n as 3. Okay, plus samples of h of n 1 2 3 4. So 4 samples you will have for the h of n sequence, -1. So 3 plus 4 7 minus 1 is equals to 6. So that means in the output sequence of y of n you will have 6 samples. You will have what? You will have 6 samples. But also we need to find what will be your lower index for the given sequence and what will be the higher index for the given sequence. Now why you require to calculate? Because where is the position of arrow we need to find. Where is the position of arrow we need to find. Now how to find lower index and how to find the higher index. Okay, see this very carefully, how to find lower index and how to find higher index. So to find lower index, that means number of samples will be having before the arrow, that is the meaning of lower index. Number of samples you will have before the arrow. Okay, suppose this is my arrow, and what number of samples you will be having before the arrow. So here it is known as lower index. Okay, and what number of samples will be having after the arrow, that number is known as higher index or high index. Okay, now see here arrow is not given, so by default this is your 0th position. So here before the arrow, before arrow there is no samples, so it becomes 0. Before this arrow there is only one sample, so +1. Here position is -1 but the number of samples is 1, so lower index will be 1. So lower index will be what? Lower index will be 1. So now arrow is by default this is your 0th position. So after this arrow you will have 2 samples. So here it becomes 2 plus after this arrow you are having 2 samples, so again we will be having 2, so that is equals to 4 samples. Now before the arrow you will have 1 samples and after the arrow you will have 4 number of samples, and position of arrow will be at 0th position. So that means at this value also we will be having 1 sample. So I am taking it as circle because this is your 0th position. So now you can see the number of samples in the output sequence is equal to 6. So 1 sample plus 4 sample, 5 samples, and at 0th position we will be having 1 samples. So total number of samples is equals to 6. In that way we need to calculate what number of samples you will be having for a linear convolution in the output sequence. Samples of x of n plus samples of h of n minus 1. So you got it is as 6. Now next one is what? How to find the lower index and how to find higher index. That means where should be the position of arrow and what number of samples you will have the before the arrow and after the arrow. So you have to take like this. Now we will see. So this is the formula for convolution, linear convolution. Y of n is equals to, that is x of n convolved with h of n, summation for k is equals to minus infinity to infinity x of k h of n minus k. So this is this signal for x of n and the signal for h of n. I have drawn here. At 0 it is 1, at 1 it is 0, and 2 it is minus 1. At 2 it is at 0 it is 2, at minus 1 it is 1, at 1 it is 1, at 2 it is 1. Now hint I have given, find lower index and higher index. So we have already calculated. Now see here, whatever the number of samples you will have, that is equals to 6. So the range of n is going to vary from, what is your lower index you got here? So lower index, how much number of samples we will be having here? So before arrow that is 0 samples and before the arrow that is 1 samples. So it is going to vary from n is equals to minus 1 2. Now here for n we are seeing the position. Now for this, now we are not seeing the what number of samples you will have for lower index, what number of samples you are having for the higher index. Now I am seeing what? I am seeing, or I am interested only in the position to calculate the range of n. Before this arrow 0 samples, before the arrow minus 1 samples. So the 0 and minus 1, it becomes what? Minus 1. After the arrow here we will be having 2 samples, after the arrow we will be having 2 samples. So 2 and 2 it becomes 4. So the range of n is going to vary from minus 1 to 4. Now you add minus 1, 0, 1, 2, 3, 4. So total number of samples it is going to be equals to 6 only. Now here we need to put the value of n is equals to minus 1, minus 1, 0, 1, 2, 3, 4. So here x of k it will remain same, h of minus k also it will remain same. What it is changed? So just we need to put the value of n and you have to multiply and you have to add. That is the graphical convolution. Now we see, I have sketched here x of k, I have sketched here x of k and h of k both. So this line indicates my 0th position, this line indicates it is minus 1, minus 2 up to it is minus 6 I have drawn, and here it is 1, 2, 3, 4, 5, 6. Okay, I have drawn. That is the position of, I have taken it as k. Now your signal is going to start from what? Your signal is going to start from minus 1. I have given you the range of n. So range of n is going to vary from minus 1 to 4. So you need to put the value of what we have to sketch. We have to sketch h of n minus k. So in this n we need to put the value of, so h of minus k means what? It is what? Just it is reverse of this. That means all the positive value, that means this 1 it is going here, and this value of minus 1 and minus 1 it is going this side. So all the positive k it is going to be a negative k, and the negative k it is going to be a positive k. So as your signal is going to start from minus 1, directly will be starting from h of, you will put the value of n as minus 1 minus k. So when you put h of minus 1 minus k, first what you need to sketch? We need to sketch h of minus k, then you have to put minus 1 minus k is equals to 0. So the value of k is equals to minus 1. Value of k is equals to minus 1. So we will be getting signal as like this. So position here, what after shifting the h of minus k. So here it is what? Here it is 0, 1, 2. So 1 and 2 it is going to be negative side, that means minus 1 minus 2, and this minus 1 it is going to be positive side. So for h of minus k, your signal is going to vary from minus 2 to positive 1, minus 2 to the positive 1. So h of minus k is going to vary from minus 2 to the 1. Now when I am going to solve h of minus 1 minus k, then we will be having k is equals to minus 1 after drawing the x of minus k. So minus 2 and minus 1 it becomes minus 3, and 1 and minus 1 it becomes 0. So you can see here signal. Here it is 0, minus 1, minus 2, minus 3. So it is going to vary from what? Minus 3 to 0. So here I have also sketched this signal h of minus 3 minus k. This is only for your understanding, and the answer for this obviously you will getting as 0, because your signal is going to vary from minus 1 to the 4. Now after that we have to sketch h of minus k. H of 0, I have put the value of n as 0, 0 minus k. So the signal is going to be same as h of minus k. Okay, I have told you h of minus k it is going to vary from minus 2 to the 1, and here you put, then you multiply. See, multiplication taking place between what to what? Between x of k and h of n minus k, then between x of k and h of n minus k. So here value is what? Here value of n is equals to minus 1. Here value of n is equals to what? Here value of n is equals to 0, and you will be getting answer as y of minus 1. Just you multiply here. See, here there is no samples, so here multiplication it is going to be equals to 0. So here there is samples and here there is not, so multiplication is going to take place for these two values also. So here at 0 the amplitude is equals to 1, and at 0 the amplitude is equals to 1. So 1 into 1 it becomes 1. Now you can see the multiplication here. So here multiplication is going to take place for these two value. Here we are having these two value, and here also we are having these two values. So at 0 here amplitude is equals to 2, and at 0 here amplitude is equals to 1. So 2 into 1. At 1 here amplitude is equals to 1, at 1 here amplitude is equals to 0. So the multiplication going to take place between 1 and 0. So 1 into 0 it becomes 0, 2 into 1 it becomes 2. So we will be getting answer as y of 0 as 2, and here y of minus 1 as 1. Similarly we have to do for n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4. So I have taken here, I have taken for your reference x of k, h of x of k and h of k. Then here I have put the value of n is equals to 1. Okay, here I have put the value of n is equals to 2, here n is equals to 3, and n is equals to 4. Then you need to multiply between these two, x of k and h of 1 minus k, x of k, h of 2 minus k, x of k, h of 3 minus k, and x of k, h of 4 minus k. So we will be getting this answer. Okay, whatever the number of samples we will be having, just you need to multiply with respect to the position of k. So we will be getting y of 1 as minus 2, y of 2 as minus 3, y of 3 as 1, y of 4 as also it is equals to 1. So I have told you the number of samples in the output sequence is equals to 6, and the range is going to vary from n is equals to, or range of k and range of n it will remain same, minus 1 to 4. Range of n and range of k it is going to be same, so minus 1 to 4. So you just put the value here. So I have got the value of y of n is equals to, you can see here, I have got the value of 1 2, then I have 1 2 minus 2 minus 3 1 1. I have written the same here, 1 2 minus 2 minus 3 minus 1 1. And where is the position of arrow? So I have told you lower index and higher index. So before the arrow you will have only the 1 samples, and after the arrow you will have the 4 samples. So the position of arrow will be at 2. So you can see here is the position of arrow. Okay, this is about the linear convolution using graphical method. One shortcut method is there. This is known as tabular method. We'll see this example. One method is known as tabular method. So this is quite interesting, or you can say it is a shortcut method. Now find the linear convolution of these two sequences, x of n and h of n. You draw this two arrow like this. You put the sequence of x of n here or h of n here. So you can interchange the position also. So I have written the sequence of x of n here, sequence of h of n here. Don't see the position of arrow here. Okay. Now you cross multiply. 1 into 1, then 1 into 0, 1 into minus 1 will be having this. 1 into 1 will be having 1, 1 into 0 will be having 0, 1 into minus 1 will be having minus 1. Similarly for 2, 2 into 1, 2 into 0, 2 into minus 1. Similarly for minus 1, minus 1 into minus 1, minus 1 into 0, minus 1 into minus 1 will be having this number of sequences. Now we have to add it diagonally. So first we'll be adding these samples. So here it is 1, addition. Then 2, 0, like this. You add, it becomes 1. You add, it becomes 2. You add, it becomes minus 2. Minus 1 and minus 1, it becomes minus 2. You add, it becomes minus 3. You add, it becomes 1. You add, it becomes 1. So whatever the sequence we have got in the earlier example, I have taken the same examples. Okay, you will get the same answer. 1, 2, minus 2, minus 3, 1, 1. So you can cross check your answer with this method also. Okay, and where is the position of arrow? Same thing we need to apply. Before the arrow 0 samples, before the arrow 1 samples, position is minus 1. So position of arrow is dash 2. Okay, in that way we have to do a tabular method. So linear convolution you can solve using graphical method also, using tabular method also, or using the mathematical equation also. So for the mathematical equation, just you need to put the value in the given equation. So the equation is what? Y of n is equals to summation for k is equals to minus infinity to infinity. Okay, the range of k and range of n, it is going to be the same, minus infinity to infinity, because here you require the range of k. So range of n and this range of k, it is going to be same, x of k, h of n minus k. So if you have to solve using the mathematical, you need to follow this formula, and here we have to put the summation of k from where to where it is ranging. We have known the value of x of k, it is similar to x of n. Then you put the value of n and you need to put the value of k, because we have the signal of h of k also.